All right, here we are in West Virginia. Are you ready for joke of the day? Because I cannot get my day going without joke of the day. It is the greatest way to start the day, and I think it is for you too. Are you ready? This is for all the track people out there, all the track stars, especially for the hurdlers. So I used to have a fear of hurdles, but then I got over it. Jump over hurdles. All right, well, let's jump into the algebra the algebra of functions. The algebra of functions simply says I can take two functions and I can add them together, which would be a sum. I can take two functions and I can subtract them from each other, which is a difference. I can take two functions and multiply them together, which is a product. And I can take two functions and I can divide them amongst each other, which would be a quotient. We know this because we've looked at this before. We've looked at being able to combine up polynomials by adding, subtracting polynomials, multiplying polynomials. We've even looked at dividing polynomials. So this idea right over here really is nothing different. What is different is getting used to this notation. So when you see this notation right here, f plus g of x, that indicates take your f function, add your g function to it. When you see this notation, f minus g of x, that simply indicates take your f function, subtract your g function. Now, if it was reversed and it said g minus f, then you would say g of x minus f of x. So you would put it in reverse depending on the order that you see. And if you see f times g of x, then it simply indicates take your f function, multiply your g function to it. And if you see this f divided by g of x, that simply says take your f function divided by your g function. And again, if you've got it reversed and it's g over f, then it would be g function divided by f function. You just need to ensure that whatever function is in that denominator, be careful about its domain. You do not want to cause a zero in that denominator. So let's take a look at a couple of examples. And in this first example, in each of the two examples that I'm going to do, we are going to find our f of g, or sorry, not f of g, but our f plus g, our f minus g, f times g and f divided by g. And then we're going to determine the domain for each one of these. First example I have here says my f of x is 5 minus x squared. My g of x is x squared plus 4x minus 12. So in my first one it says let's add the two together. So I'm going to take my f function and I'm going to add my g function. And what that tells me is I'm going to take my 5 minus x squared and I'm simply going to add my x squared plus 4x minus 12. And I'm going to see what happens when I combine up those like terms. Thought I was getting ahead here, but I'm not leaving myself enough space. So at this point you can see I'm simply going to combine up like terms. So a negative x squared plus an x squared cancels out. The 4x squared doesn't combine with anything, so it is left. And then my 5 minus 12 will give me a negative 7. So here is my f plus g. It's simply a 4x minus 7. Now let's take a look at that f minus g that I erased a minute ago. And what that says is take my f function and subtract my g function. So here is my f function, 5 minus x squared. And this says I'm going to subtract the g function right here, x squared plus 4x minus 12. Now you know that when you subtract, you need to distribute the negative through. So I'm going to distribute it through and I'm going to get 5 minus x squared. When I distribute, I get a negative x squared minus 4x plus 12. And now I'm going to combine up those like terms. Negative x squared minus x squared is a negative 2x squared. That negative 4x doesn't combine with anything. And 5 plus 12 will give me a 17. So this is what my f minus g will look like. Now let's take a look at f times g, which indicates take the f function and multiply it to the g function. Now when I do that, f function is 5 minus x squared. G function is x squared plus 4x minus 12. And now you know when you see this, you're going to do that extended distributive property, a bigger FOIL. So I'll take 5 times x squared and I will get 5x squared. 5 times 4x is 20x. 5 times negative 12 is a negative 60. Negative x squared times x squared is a negative x to the 4th. Negative x squared times 4x is a negative 4x to the 3rd. And negative x squared times negative 12 is a positive 12x squared. So now I'm going to combine up those like terms. Nothing combines with my negative x to the fourth. And third power, nothing combines with it. So I've got a negative 4x to the third. Now my second power, here and here, they combine to be a 17x squared. First power here, nothing combines with it. And in the back of that, negative 16, nothing combines with it. So this is what my f times g will look like. Now let's do f divided by g. Let's flip this over to the other side where I've got a little bit more room. And that f divided by g would simply indicate take the f function and divide it by that g function. Well, recall the f function is 5 minus x squared. The g function was x squared plus 4x minus 12. And once I've got that, the only way that I can simplify that fraction is for my parentheses, or not terms to cancel, but to factor the numerator, factor the denominator, and get factors to cancel. Now this will factor as an x, let's see here, x plus 6, x minus 2. And the only way for this to cancel with that is if this would factor in any way, shape, or form as an x plus 6 or an x minus 2. And that certainly will not happen, because the only way to break up a 5 is as a 5 and a 1. So I know that this will not simplify, and this itself is my f divided by g. Now, let's go back and take a look at the domain as we were asked to do. So when you look at that domain, remember the whole issue is I want to ensure that I do not have zeros in denominators of fraction. I want to ensure that I do not have negatives underneath square roots. Well, if you look at this result here, or actually go back to the beginning and look at the domain here, no, I'm going to look at the end result. In the end result, I don't have any fractions either anyways, and I don't have any square roots to worry about negatives underneath the square root. So there is no restriction on the domain for that one. If there is no restriction, then that means my domain goes from negative infinity to positive infinity, because that indicates to me everything is going to be perfectly fine to plug into this particular function right here. Once I have combined the two and added them up, what is the domain for the result? What can I put in there for that x? Everything's okay to put in. Now take a look at this one. Similar idea. I don't want zeros in denominators of fractions. I don't want negatives underneath radicals. I don't have either of those cases in here. So yet again, my domain is going to be negative infinity to positive infinity. Every single number I can think of is going to be okay to put in all these x's for the result when I take my f function, subtract my g function. Similar thing here as I look at this, no fractions, no square roots. I don't need to worry about anything here as well. So that means once again my domain is negative infinity to positive infinity. There is my domain. Every single number that I can think of is okay to put in for these x's for the result of when I multiply my f function and my g function. And then finally, let's take a look at our division, our quotient. Oh, we do have a situation here. We do have a fraction here. I don't want this x squared plus 4x minus 12. I do not want that to be a 0. So the easiest way to do it is to say, well, let's look at its factored form and make sure that that doesn't end up as a 0. Which means that that x plus 6 had better not be a 0. That x minus 2 had better not be a 0. So here, my x had better not be a negative 6. Here, my x had better not be a 2. So these are my restrictions on the domain. Now remember, I was asked, what is the domain? So my domain can be everything, every single number that you can think of, except for that or that. I don't want those two. So if I picture my number line, here's 0, here's 2, here's negative 6. Everything back here is okay, just not that. Everything up here is okay, just not this. And everything in between is okay. So that means that my domain is going to be everything from a negative infinity up to the 6. Remember, the 6 is not included. It gets a parentheses. I'm going to skip over it and pick just on the other side of that 6, go all the way up to a 2. The 2 is not included. It gets a parentheses. Skip over it, pick up on the other side of the 2, and go all the way up to infinity, which gets a parentheses. And like we said before, these are not three separate intervals. They are all together for one big picture. So the way that we signify, oh, I want them all together, is to put that U between them, the union. And so that is the domain for the division, the quotient of the two functions. Now, let's take a look at a second example. Flip this around, enjoy that scenery. And let's get a new example in here. Okay. So this time my f function is going to be a square root of x, and my g function is going to be x minus 5. And I'm going to do the very same thing. I'm going to add the functions, subtract the functions, multiply the functions, and divide the functions. So when I go to add the functions and do f plus g, remember that means take the f function and add the g function to it. My f function is square root of x. My g function is x minus 5. So I'm going to take the f function and add the g function. I'm going to try to combine up the like terms, but notice there are no like terms that I can combine. So therefore, I'm just going to get a square root of x plus x minus 5. That is what I get whenever I add the two functions. Now let's take a look at the difference, which means I'm going to take my f function and I'm going to subtract my g function. Here again, what that indicates is take this f function of square root of x and let's subtract the entire g function, all of it. And recall what that indicates is I need to distribute that negative through and get a negative x plus 5. Combine up any like terms, but there aren't any. So this is what my subtraction difference will result. Now my product, f times g, means take the f function and multiply it to that g function. Now my f function again is square root of x. My g function is x minus 5. And so I'm going to distribute it through. Now when I distribute, it depends on what you're dealing with. Some will just let you leave it like this and call it a square root of x times x minus 5. Some textbooks, some professors, some teachers will let you just call this your f product g. But some, however, say, well, wait, that is an x to the 1/2. And so therefore, when I distribute it through, I'm going to add these two exponents because I'm multiplying the bases, and I'm going to get an x to the 3/2 because this is 1/2, or sorry, not 1/2, but 1, and 1 is 2 over 2. 2 over 2 plus 1/2 is 3/2. And when I distribute here, I get a minus 5x to the 1/2. So again, it just kind of depends on your instructor and your textbook as to which one of these two, how far you have to take it. Now, let's take a look at the division. Flip that around here. And recall that the division simply meant take the f function and divide it by the g function. So if we recall that f function was square root of x, my g function was x minus 5. Now there's nothing that I can do here because I can't just cancel out these two because I can only cancel factors. These are not factors. These are a difference. They're being subtracted. So I can't just cancel out the x's. So there's nothing that I can do to simplify this. It is done. Now let's go back and look at the domain for each one of these. Recall with domain, I want to be very careful that I don't want zeros in the denominators of fractions. I also do not want negatives underneath radicals. Now as I look at this result here, I don't have any fractions. That's great, but I do have a radical there. I want to ensure that this is not a negative number. So basically what that means is I have nothing under there but an x, so my x's need to be positive numbers. Now is it okay for that x to be a 0? Absolutely. So that means that my domain on this one, I just need to ensure that x is 0 or anything bigger than 0. Picture that number line. Here's 0. All the negatives are back here. I don't want that to happen. Everything up here is okay. But remember, the 0 itself is okay. So it gets a bracket or a closed circle. And so that means everything from 0 up. So my domain begins with 0, goes to infinity, which always gets a parentheses. The 0 is included, so it gets a bracket. So there's my domain for the sum of the two functions. Now let's take a look at the difference. Here again, I don't want zeros in denominators of fractions, but I don't have fractions. I don't want negatives underneath radicals. Aha, there's a radical. But like in this one, there's only an x. So it's a similar situation here that I just want to make sure that there's no negatives in there. 0 and anything bigger is okay. So my domain is the very same thing here. From 0 to infinity. And once again, 0 gets that bracket because it is included. 0 is okay to put under there because square root of 0 is 0. Not a problem. Now take a look at this one. Here's what I'm dealing with. This is okay. I mean, it's a fine answer, but in terms of dealing with the domain, this is easier to understand. Once again, no zeros in the denominators of fractions. Don't have fractions. I'm only worried about this. And yet again, just like with the other two, it's just an x under here, nothing else. So my domain then is going to go from 0 to infinity, just like the other two. Now, let's take a look at our quotient. And with that quotient, I have a couple of things happening. I still have that radical that tells me when I look at my number line, I need to ensure that nothing back here is going on. It needs to be everything up here. However, I have a fraction. I need to ensure that that denominator, that x minus 5, it had better not be a 0. Which means that my x had better not be a 5. So where I said everything up here is okay, well, everything except for that 5 is okay. Everything but skip over the 5. And remember, the 0 itself is okay because it's okay to put a 0 here. 0 minus 5 is a negative 5. Not a problem in that denominator. Put a 0 in here, square root of 0 is 0. So 0 is fine. Everything above 0 is fine, just not the 5. So that means when I speak about this domain, I'm going to start at 0 and include it. I'm going to go up to the 5 and go, whoa, that's not included. It gets a parentheses. I'm going to skip over it and pick up on just the other side of that 5. And then I'm going to go on forever. But remember, these are not two separate intervals. They're part of one big picture. And the way that I signify that is I put a union between them. And so there's the domain. So hopefully that helps with the algebra of functions. And like I'm hoping that you saw, it really comes down to understanding the notation. When you see this notation, that simply means add the two functions together. When you see this notation, it simply means subtract the two functions. This one simply means multiply the two functions, and this one simply means divide the two functions. But be very careful about that domain. You don't want zeros in denominators of fractions. You don't want negatives underneath radicals. So I hope that helps. Have an awesome day.